So let's get started with S1, and the focus is on probability. The focus is on probability distribution. Now, in probability distribution, what exactly do we study? We study about making a probability distribution table with X and the corresponding probability, and then calculating expectation of X as well as calculating variance of X. That is what we focus on. So now that is one thing. And what is the next thing? The next thing is, what are the different ways of forming this probability distribution table? So that is based upon probability. It could be related to a tree diagram. It could be related to combinations. It could be related to permutation. It could be related to maybe a table. And based upon the table, you'll be getting all the information, and that's how a probability distribution is created. Now, a particular case, or maybe two particular cases of probability distribution, also includes binomial probability distribution and geometric probability distribution. So just to get things in the right perspective, let's just go over what is binomial, what is geometric. First of all, they deal with discrete values, discrete random variable, and hence the name DRV. So yes, it's part of DRV, it's part of probability distribution, but there is a formula based upon which we can work it out. So for binomial, we talk about N, that is the number of trials. We talk about P, that is the probability of success. We talk about Q, that is probability of failure. We know that P plus Q adds up to 1. There is no third probability. Either something will happen or something won't happen. We talk about R, that is calculation of probability for a required term. So yes, we do have a formula. And what formula is that? That formula is X follows a binomial distribution N comma P. These are the parameters. N is the number of trial, that's right over here. P is the probability of success. Q can be found from here. And then we write probability X is equals to R, that is NCR. Probability of success raised to power of R, Q raised to power of N minus R. So that is the working that we do. We also have the knowledge that expectation of X is NP. We also know that variance of X is NPQ. We know that standard deviation is square root of variance, hence square root of NPQ. Now, there could be some standalone simultaneous type questions based upon these formulas. We can use them, and we do use them for normal approximation to binomial. Every distribution wants to become normal. So there are certain conditions that needs to be fulfilled. What are those conditions? NP greater than 5, NQ greater than 5, and then we have to do something known as continuity correction. So that is the story of binomial. Naturally, we would be looking into questions and then going over them. And now let's talk about geometric. So if we talk about geometric probability distribution, so geometric, it's about there is no N. That is the first thing. Yes, there is P, there is Q. And let me write the formula first, or even the distribution first. X follows the geometric distribution with P. And probability X is equals to R, that is P comes at the end. It has a power of 1. And Q has a power of R minus 1. What is the concept over here? The concept is that as soon as you achieve success, you keep on going until, this is a keyword, you achieve success. Whether it's tossing a coin, whether it's rolling a dice and looking for a particular number, as soon as you achieve success, what do? You stop. So that is why the ending of this formula is at P. Naturally, geometric probability distribution is derived from geometric progression. Binomial probability distribution is derived from binomial expansion of P1. And in binomial, there are certain conditions that needs to be fulfilled. So sometimes they do this asked this question. That is for binomial probability distribution. Certain conditions needs to be fulfilled. What are those conditions? The number of trials are fixed. The number of trials are independent of one another. And let me explain in the context of a question. And then the probabilities are fixed. That means something without replacement scenario that cannot be termed as binomial. And if we talk about geometric probability distribution, so we just have to focus on this, that probabilities are fixed. So probabilities are fixed. Therefore, without replacement scenario cannot become a geometric distribution scenario. So that's more or less about this. Now let's look at some questions. Let me start with this thing that is over here. Let me go to the favorites and let me put the pen in charging. So we are going over here. Favorites, we will start with this. Now let's look at this question, this second one. Just read through it. The solution is already there. Just first read through it. It says an ordinary fair die is thrown repeatedly until a 1 or a 6 is obtained. Now, this first statement, that is the most crucial one. You have to decide whether it's geometric at this stage, whether it's binomial. Since the number of trials is not mentioned, therefore it cannot be binomial. That is the first checklist. The second thing, the word until is there. As soon as you achieve success, you will stop. So these two things tells us that this is a geometric probability distribution. Decide on the distribution first, then start with the working. Now it says until a 1 or a 6 is obtained. What is this? This is giving you the idea that you have to infer, you have to deduce what is the probability of success. So success is getting 1 or 6. Two numbers out of 6 possibilities in a normal ordinary fair die. That is a 6-phase die. So the probability of success is 2 out of 6, yeah, 1 out of 3. Over here, I have first written this thing as what? I have written it separately, probability of 1, probability of 6, 1 or 6. I added it up. You can write it directly. Until geometric, I have given the reference of one of the earlier questions. I think it was either November 04 or November 05, one of the first S1 questions in which they asked about geometric. At that time, geometric was not part of the syllabus. So they asked it using common sense. Geometric became part of the syllabus from June, or maybe from the Indian perspective, from March 2020. That's when it became part of it. Before that, it was not part of it. So that is a little bit historical reference. X follows a geometric distribution 1 over 3. Probability of success 1 over 3. Probability of failure 2 over 3. So this is just based upon this first line. Now I was just going through something. So let me just going through this thing just off the record. That when we look at what are the outcomes that Cambridge wants to develop in students. So this is the thing that they talk about. That engaged, confident, responsible, reflective, innovative, and so on. So one of the things is that confident in using mathematical language techniques to ask questions, explore ideas, and communication. And then it's about reasoning, problem solving, collaboration, thinking creatively, becoming curious. So these are the objectives that Cambridge wants to develop in you. So I was just going through it. I mean, I just broke it up into 2 parts. So the blue part is these are the things that they want you to understand. Red part is this. These are the things that should be developed. So now coming back to this, where is it? Okay, this one. So now over here, this first line was about that curiosity, that creativity, that understanding, inference. Now the second part. Find the probability that it takes at least 3 throws, but not more than 5 to obtain a 1 or a 6. At least 3. It could be 3, it could be 4, maximum could be 5. So now I'm using the formula. Success is at the end. That is written in black. For 3, the total terms should be 3. So it's basically 2/3, 2/3, 1/3. Failure, failure, and then eventual success. So we are using indices. There are 2 failures and 1 success. In 4, there are 3 failures, 1 success. In 5, there are 4 failures, 1 success. That's how this question is done. You find the answers, you add it all up, and then you get the answer. Make sure you work in fractions. Do not round off. Do not torture yourself or the examiner. Now read this part. It says, on another occasion, the die is thrown 3 times. Now number of trials is mentioned. The random variable x is the number of times that 1 or 6 is obtained. Now, this is nothing. This is for making a probability distribution. This does not make this question a binomial one. This makes it. The probability, the number of trials is there. Probability of success is the same because it's the same scenario as before. Now the word until is not used because different outcomes are possible. The ordering could be different. In geometric, the ending should be success. So now it says, draw up the probability distribution table for X. Very simple. Number of trials, probability of success. There are 4 options. Probability X is equals to 0, X is equals to 1, X is equals to 2, X is equals to 3. You get all the 4 probabilities. You write it in a table, and then you get the answer. If they ask for expectation, either you can use this thing and you get the same answer. The formula for expectation is sigma xp. Take each x value, multiply it with the corresponding probability and add it up. Or since you are considering it binomial, and it is binomial, so just use NP and you will get the same answer. So now this is the first question that we came across. The second question. Just have a look. Now the question says, box A contains 7 red, 1 blue ball. Box B contains 9 red, 5 blue balls. A ball is chosen at random from box A and placed in box B. So you have seen some questions like these before. A ball is then chosen at random from box B. The tree diagram below shows the possibilities for the colors of the balls chosen. Complete the tree diagram and show the probabilities. Now, first of all, there was nothing complete over here except for the fact that they have written box A, box B, and the diagram, the tree was drawn. The tree was empty. 7 plus 1 is 8. That is the 8 over here. 7 red, 1 blue. That is the first basic thing. We are taking 1 from box A and placing in box B. 9 plus 5 is 14. Since 1 more is coming up, therefore the denominator in all of them is 14 plus 1, which is 15. Red and then another red. That means initially there were 9 red. 1 red is transferred. So 9 plus 1 becomes 10. This 5 is the same as before. Why? Because the red was transferred, blue remains unchanged. By the same standard, blue to blue, this 1 extra, I mean, even though there is 7 over here, just want to make sure of one thing. The 7 is there, that is 7 possibilities out of 8. But 1 ball is transferred, so only 1 is there. This 1 ball was there, still 1 is there. So do not think that this is 7, so this should be 7, this is 1, this is 1. That's not the case. I just want to erase that misconception. 1 ball is transferred. So now there were 5 blue balls initially. 5 plus 1 becomes 6. This 9 is the same as this 9 over here. Also, we should always double check. 9 plus 1, 10. 10 plus 5, 15. 15 over 5, 15 is 1. 9 plus 1 plus 5, another 15. 7 plus 1 is 8. In each branch, all the probabilities, whether 2 branches, 3 branches, they should always add up to 1. Also, the final answers, they should also add up to. Next thing, do not reduce the fractions. Leave it as it is. This is 8, this is 15. 8 into 15 is 120. So all these denominators should be 120. Even if reduction is possible, do not reduce, because it's very easy to check your answers. 7 into 10, that would be 70. 7 into 5, that would be 35. 1 into 9, that would be 9 over 120. 1 into 6, that is 6 over 120. So you can just multiply the denominator separately, numerator separately. I mean, I have not done the whole question. Let me try this out. So therefore, let me write 120 over here in all of them. And over here, 7 into 10 is 70, 7 5s are 35, 1 into 9 is 9, 1 into 6 is 16. Now let's just double check. 70 plus 35, 105, keep it on the side. And 9 plus 6 is 15. 105 plus 15, 120, 120 over 120 is 1. Then it says, find the probability that the two balls chosen are not of the same color. That means they are of different color. So different color is RB plus BR. So this is RB, this is BR, 35 plus 9. How much is that? 44. So this is 35 plus 9 over 120, which is 44 over 120. Find the probability the ball chosen from box A is blue, given that the ball chosen from box B is blue. Now, this has nothing to do with part B. This is different. Ball chosen from box B is blue. That means it could be red blue, it could be blue blue. So let me choose this. It could be red blue, it could be blue blue. That is 35 plus 6. So this is 35 plus 6 over 120. That is the condition. Condition goes down in the denominator. So whatever is written after given, that is the condition. If they are talking about future, they might use if also. Condition goes down in the denominator. That is the first thing. And whatever is the relevant thing out of the condition, that goes up. What is the relevant thing? Ball chosen from box A is blue. Ball chosen from box B is blue. Naturally, it should be out of the condition. So blue, blue goes up. So blue, blue is which one? Blue, blue is this one. That is 6 over 120. Now look at the working. We have 6 over 120 divided by, how much is that? 35 plus 6, 41 over 120. So therefore, 120, 120 would cancel out and we are left with 6 over 41. Answer in the exact form. So now that thing is done. Let me move to this one. Another question, a geometric and probability distribution. Just have a good look. The score when two fair-sided dice is thrown is the sum of the two numbers on the upper faces. Okay, so now two fair six-sided dice is thrown. That means 6 into 6 is 36. Now it says, show that the probability that the score is 4 is 1 over 12. Now, what are the different ways of obtaining a 12? So it could be obtaining a 4. So it could be 1 plus 3. It could be 3 plus 1. It could be 2 plus 2. So there are 3 options over here. So 3 options out of 36. The answer comes out to be 1 over 12. That is the first thing. Now the next thing, it says the 2 dice are thrown repeatedly until a score of 4 is obtained. So answer of part 1, that is the probability of success. Until is there, that means it's geometric. Number of trials is not there, that further means it is geometric. The number of throws taken is denoted by the random variable x. Find the mean of x. What is the formula over here? In geometric, we are only considering the formula because that's part of the syllabus. That is the formula for expectation, which is the reciprocal of number of trials. We are not interested in the formula for variance because variance is not part of the syllabus for geometric. For binomial, both are part of the syllabus, but for this thing, only this. So find the mean of x. So the reciprocal of 1 over 12 comes out to be 12. That's the first basic thing. Now it says, find the probability that the score of 4 is first obtained on the 6th row. That means 6th is your success. There should be 5 failures. So failure probability could be written 5 times, multiplying by itself, or you can use indices. So 11 over 12 raised to power of 5 into 1 over 12. The next one, find the probability x is less than 8. Now there are two formulas which are very, very useful. Instead of working out the whole thing, let me write them in a box. So let me create a box. This thing. Let me create another box. Now the two formulas are these. That is probability x is lesser than or equal to n. So probability x is lesser than or equal to n. This is 1 minus probability of failure raised to power of n. And the other formula is probability x is greater than n. That is q raised to power of n. So you just have to use this formula. Now let's say over here, what have they asked? They have asked x is less than 8. It does not fit this. It does not fit this. Yes, it almost fits this except for the equal sign. So less than 8 is basically less than or equal to 7. So you have to realize this, then apply the formula. It's as simple as this. Over here, x is greater than n. Let me say that if I ask you x is greater than or equal to 5, what should it become? Greater than 4. Because if I move to 6, I would be skipping out 5. So go one step back. So that is probability x is greater than 4. That would be q raised to power of 4. That would be 11 over 12 raised to power of 4. Okay, this thing is also done. Okay, this is a permutation which we did before. Okay, a question related to a table like this. It says a total of 500 students were asked which one of the 4 colleges they attended and whether they preferred soccer or hockey. The number of students in each category are as shown in the following table. Soccer, hockey, total. So this is A, B, C, D. 4 people are there. This is the data for soccer. This is the total number of people playing soccer. This is the total number of people playing hockey. These are the students in each category, 4 colleges. Okay, so there are 4 colleges. College A, there are total 86 students. B, 156. C, 78. D, 180. This way it's adding up to 500. This way it's adding up to 500. That means each person belongs to only one category. That means a person studying in college C and playing soccer is not playing hockey. Neither could he be in any other college. So now this thing is there. It says find the probability that a randomly chosen student in C college prefers hockey. Randomly chosen student, denominator is 500. Prefers hockey, C and hockey. This is 56. Basic question, 56 over 500. No need to simplify because they're not asking us to. So why should we waste our time? The next thing. Find the probability that the randomly chosen student is at D college given that he prefers soccer. Given as condition. Condition is he prefers soccer. So preferring soccer is 280. And it says he is studying at Dever College. So I just chose 280 directly. Technically, 280 is the sum of all these 4. So deliberately, in order to make you understand, I've written all these 4 things. And then I am choosing the number of students at D college, so that goes up. So that you again have a feel that whatever is in the condition, something relevant out of the condition goes up. So 120 over 280. Third part. One of the student is chosen at random. Determine whether the events the student prefers hockey and the student is at A or B college are independent, justifying your answer. So now over here, I have written the equation for independence. Probability of C and D, or we can also write intersection. That is probability of C, probability of D. That means if I take the individual probabilities, I multiply it out. If it equals to the intersection probability, it's independent, statistically independent. If it's not, it's not. If it's not equal, it's not independent. Probability of hockey 220 over 500. Probability of A or B college. So how did I choose that? I chose 86 plus 156. That comes out to be 242 over 500. Then probability of both H and AB. That means it could be hockey from college A. It could be a hockey from college B. 32 plus 72, that is 104. So this 104 over 500 is there. Is this value equal to these two multiplying together? I did not multiply it out. I don't think so it's equal. So you can just check it. If it's equal, we would say it's independent. If it's unequal, it's not independent. Let's move on. So let's look at this question, a question of DRV. Just go through it. Now the question says, a fair three-sided spinner has side numbers 1, 2, 3. 1, 2, 3. This is a fair spinner. All the probabilities are 1. Now, why does it say fair? I'll just explain in a short point. A fair five-sided spinner has sides numbered 1, 1, 2, 2, 3. Both spinners are spun once. For each spinner, the number on the side on which it lands is noted. The random variable X is the larger of the two numbers if they are different. It's not subtraction, it's just choosing larger of the two numbers. And their common value if they are the same. For example, 1, 1, they are the same. I'll just write 1. But 1 and 2, 2 is the larger, I'll write 2. 1 and 3, 3 is the larger, I'll write 3. Now, in this question, since both dice are fair, so whatever things that you see according to the rules that they have described in the sample space diagram, probability will be based upon this. Let me first finish it and then let me present you a scenario in which if it was not fair. So if I want to find what is the probability of scoring a 3, that is right over here. So I'll choose 1, 2, 3, 4, 5, 6, 7. That is 7 out of 15. That's it. Let's say if it's unfair. So they would have given me the probability separately. For A, this is 0.4. For B, let's say this is 0.3. And let's say C is also 0.3. I'm just giving you an example. And for these 1, 1, 2, 2, 3, maybe this was fair. So of everyone has a 20% probability. Then if I talk about scoring a 1, so that could be 1 from X, 1 from here, I would be multiplying out the probabilities. Scoring this one and this one, I would again be multiplying out the probabilities and then adding 1. We have done questions like that. But this is a simplified question. Draw up the probability distribution table for X. That's very easy. We have 1, we have 2, we have 3. From the table, we write down all the probabilities. We also make a row for X square. Expectation of X, that is sigma Px, 1 into 2, 2 into 6, 3 into 7, divide once by 15. Expectation of X squared, that is sigma Px squared, 1 into 2, 4 into 6, 9 into 7, and that divided by 15, that comes out to be 89 over 15. Variance of X, expectation of X squared minus expectation of X, the whole thing squared. So that is what you get over here. That is question 5, expectation variance already done. Okay, let's see. Something like this. On any given day, the probability that Moina messages her friend Pasha is 0.72. Find the probability that for a random sample of 12 days, binomial, Moina messages Pasha on no more than 9 days. So that is at most 9, correct? At most 9 means no more than 9 days. So first of all, the data for binomial, it should be clearly stated. X is lesser than or equal to 9. The inequality should be clearly stated. That's too much to calculate. What is left? 10, 11, 12. Calculate the probability for each one of them according to the formula. Add it all up, subtract it from 1. Moina messages Pasha on 1st Jan. Find the probability the next day on which she messages Pasha is 5th Jan. So she messages on the 1st Jan, just ignore that. Then there are 3 days of no messages and the 4th day. 5th January is the 4th day. She messages. So no, 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 and then message, 3 failures, 1 success. Correct? The next one. This is normal approximation. Let's just go over it. Use an approximation to find the probability that in any period of 100 days, Moina messages Pasha on fewer than 64 days. Of course, we have studied normal approximation to binomial. We have not studied normal approximation to geometric. So it does not exist. It cannot exist. Because if there is no n, how can you convert NP, NPQ, or whatever like that? So at least to our knowledge, it does not exist. So just ignore that. Normal approximation to binomial. X follows a binomial distribution 100, 0.72. This is N, this is P, this is Q. Calculate each thing separately. NP is there, NQ is there. These two are for justification, whether they ask for it or not. NPQ is variance. Greater than 5, greater than 5. Yes, it's justified. Now choose, let me highlight this. Now choose 72. And let me make it bigger. Yeah, it's bigger. And now choose 20.16. So that becomes your NP and NPQ. That becomes your mean and variance. And then it says on fewer than 64 days. And the last thing is continuity correction. Fewer than 64, you cannot choose 64 because this came from discrete probability distribution. The lower limit and the upper limit, according to O-level math, IGCSE, is 63.5 and 64.5. Since you are going in this direction, there are 2 possible options. Which is the correct one? Since this is not inclusive, the red line is the correct one. Probability X is less than 63.5, and then it's back to normal distribution, and then you get the answer. Okay, Ji, this thing is done. Now, there is one permutation question that I would like to explain. Because yesterday I talked about that thing, that if we are dealing with selection from identical objects. So when we are dealing from identical objects, if we are doing the selection, we just pick one and drop away the rest. But if we are talking about probability, we just treat it as normal. So this question, let me explain it. Find the number of different possible arrangements of 9 letters in the word celestial. That is basic. Find the number of different arrangements of 9 letters in the word in which first is C, 5th is T, last is E. So now 6 spaces are left. So 6 factorial, 2 factorial, because there are 2 L's. Find the probability that the randomly chosen arrangement, it's still arrangement, of the 9 letters in the word does not have the 2 E's together. So that is the space concept, or you can also do it by subtraction. I prefer the space concept. 8 spaces, 2 E's needs to be fitted in, 8p2, divide by 2 factorial because both are E's. Now, these 7 alphabets, they arrange themselves in 7 factorial ways. Divide by 2 factorial for the 2 L's. That comes out to be this. Probability 70560 divided by 90720. What is 90720? That is the answer of part A without any restriction. They were asking for probability. So permutation, 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 that's the first 3 parts. Now, this one, it says 5 letters are selected. It is still a question of selection. So NCR won't work for identical objects in selection. Find the number of different selections of 5 letters that include at least 1 E and at most 1 L. So there are 2 E's, there are 2 L's, at least 1 E, that could be 1 or 2 E. At most 1 L, 0 L or 1 L. So I've made different combinations. I have fixed this at 0. I have changed to 1 and 2. I have fixed this as 1. I have changed it into 1 and 2. And then since I need a total of how many? 5. So in this case, 1 is chosen. The remaining 4 are chosen out of 5. 2 are chosen. Remaining 3 are chosen out of 5. 1 is chosen. Remaining 3, 1 plus 1 is 2. 2 are chosen. Remaining 3 out of 5. And 3 are chosen. Remaining 2 out of 5. This is the answer. Now in 2023, there was this question, and there was one question, and I think 2021 also. tomorrow, I think. 4 letters are selected from the 9 letters of the word Andromeda. NCR works normally. Why? Because now I'm dealing it as a probability question. Because in probability, let's say I have 3 identical $100 bills in my pocket. So if I choose one, it's 1 out of 3. So identical doesn't make a difference in probability. As far as arrangement is concerned, every single $100 bill is a $100 bill. So it does not make a difference which one I choose. So there is a difference between the two. Find the probability that the selection contains at least 1D and exactly 1A. At least 1D, it could be 1D, it could be 2D, exactly 1A, exactly 1A, exactly 1A. Now in this thing, Andromeda, there are 2 A's, 2 D's, NROME. So I'm choosing 1 out of 2, 2C1. I'm choosing 1 out of 2, that's 2C1. I'm choosing the remaining 2 because I need 4 letters out of 5, that's 5C2. Similarly, I'm choosing 1 out of A and 2 out of D and 1 out of 5. So 2C1, 2C2, 5C1. And that's how we get this answer. Without any restriction, it's 9C4. So that is one thing that I wanted to focus yesterday. Now let's look at this one. Now this is the concept of that again, A intersection B, the common thing, the union thing, something like that. Now it says 2 ordinary fair dice, 1 red, 1 blue are thrown. Event A, the score on the red is divisible by 3. Now, even though we are throwing 2 dice, 1 red colored, 1 blue colored, event A only relates with the red die. So there are 6 options. It's divisible by 3. So it's 3 and it's 6, 2 out of 6, 1 out of 3. That is the answer. Now the next one, let me just highlight this answer in green. So this is the answer for probability of A. Now the purple thing, what is that? The purple thing is the sum of the 2 scores is at least 9. So it's your choice. You can draw a full-fledged 36 possibility diagram, or you can realize the fact that in order for the score to be 9 or above, so the very first option is 3, 6. Up till 2, 6, that would add up to 8. 3, 1, 3, 2, that is 8. 3, 1 is 7, 3, 2 is 8, 3, 6 is 9. So 3, 6, that's the only one. Then 4, 5, 4, 6, then 5, 4, 5, 5, 5, 6, then 6, 3, 6, 4, 6, 5, 6, 6. The orders are already taken into account. Now somebody might be thinking, why are we not multiplying by 2? We are not multiplying by 2 because the order has already been taken. 4, 6 and 6, 4, it's right over here. 5, 6 and 6, 5 is right over here. These are 3, 6 and 6, 3, that's right over here. Everything is taken into account. So therefore, the answer of this thing is 10 over 36. The answer of A is 1 over 3. Now, how many common ones are there? That is a good question. Now, the common ones, probability of A intersection B, let me just choose the color. So this thing, probability of A intersection B, which one is that? That means not only the red die is divisible by 3. So now there are 2 choices. Either you look over here or you look over here. The options are already written over here. So look over here. The number on the red die is divisible by 3. That's one option. That's this is 1, this is 2, this is 3, this is 4, this is 5. So there are 5 options from these. From these 10 possibilities, there are 5 options which are divisible by 3. The number on the red die is divisible by 3. So this comes out to be 5 over 36. Now they can ask us 2 questions. Are these 2 events mutually exclusive? I will say no, because if it's mutually exclusive, there should be nothing in common, but there are 5 options in common. So definitely it's not mutually exclusive. The other question that they can ask is that, are these 2 events independent? So I'll say if this intersection is a product of, is equal to the product of these 2, it's independent. Otherwise, it's not independent. So that is what they have asked. 5 over 36, is it equal to 1 over 3 into 10 over 36? I have written a question mark on top of the equal sign. It's not equal. It's not even close by. So therefore, it's not independent.